Getting to this point to find methods to calculate various characteristics of your parabola. At this point, it's important we talk about how to do a sketching question. A sketching question will not expect you to, with extreme accuracy, draw out a graph, space it all out one apart. What I want you to do is show that you can find the key aspects of that graph, the key characteristics, and that you can translate that and you understand what each of those is on the parabola. And we'll talk about what that means throughout. We've been given this quadratic already factorized, which is lovely, and it honestly doesn't affect anything other than the fact that when you have to find the roots, you do not have to factorize it yourself. And this is quite a common way that they lower the difficulty of the question so they can test you on the nitty-gritty that they really want you to be tested on. So first off, let us find the roots. So the roots, how do we do that? Well, you think at the side, you make equal to 0, you factorize, you split, and you solve. So what we have instead is now f of x equals x minus 3, x plus 1. We are going to have x minus 3, x plus 1 equals 0 for roots. Done. It's already been factorized, so we didn't even have to worry about that one. We now split it up. So either x minus 3 equals 0, or, and remember, or is important, x plus 1 equals 0. Tick. And you solve. So x equals 3, or x equals minus 1. X equals minus 1. Done. You have found your two roots. Now, when it comes to sketching, this is what I mean. So you say, well, 1 in will be minus 1. And then you do roughly the same size jump. And you say that the other root is at 3. I've not measured it with a ruler, but nobody would look at that and think that I was completely making that up. The jumps are approximately the same size. I clearly understand what the roots are. So we've done the roots. We are now looking at the y-intercept. So the y-intercept I'll do in green. How do we find the y-intercept? At the y-intercept, x equals 0 because you are on the y-axis. So we have f of x equals x minus 3, x plus 1. And we are going to make x 0. So f of 0 equals 0 take away 3, 0 plus 1. Now this is where most people get confused. Remember, your brackets are multiplying. That was the whole reason we could split it up in the first place to find our roots. These brackets multiply. So we have minus 3 times positive 1, which gives you an answer of minus 3. Don't fall into the trap of thinking that that's adding. It's such a common mistake. Brackets mean multiply. So we've got our y-intercept. We go back to our graph and we mark it on. We're going down 1, and again, roughly the same size spacing, 2, 3. So we cross the graph at minus 3. We've got our y-intercept. We now have to find our turning point. So how do we find the turning point? My technique for this was always to first find the axis of symmetry. So axis of symmetry. And that will be in the middle of -1 and 3. And I'm thinking, what's in the middle of -1 and 3? If you're not sure, -1 plus 3 divided by 2. So -1 plus 3, that's 2 over 2. That just gives you 1. So our axis of symmetry is x equals 1. We're going to use that because remember, your axis of symmetry is going to go through your turning point. So x equals 1 at turning point. We sometimes write that TP. So f of 1 equals 1 take away 3 in a bracket, 1 plus 1 in a bracket. All I've done is taken that original expression and substituted in 1 instead of x. And we work it through. 1 take away 3 minus 2. 1 plus 1, that's positive 2. We remember that brackets means multiply. And we've got -2 times 2 gives you -4. Take the 1 second, it's getting quicker the more we do this, to write down your coordinate. X is 1, y is -4. And then you go to your diagram, you go down a 1 further, in 1, and that is your turning point. So I have marked the important features of this parabola. Nobody could argue that that will define my parabola. And what I need to do is join them together in as graceful a curve as I can. So I want to go through all of those points in my best parabola shape, trying to make it as symmetrical as possible. And this is why we quite often tell you to use a pencil, because the great thing about that is you can go over the same line and improve it until you are happy that you have done a symmetrical graph and you have shown your roots, your y-intercept, and your turning point.